Assalamu alaikum. Welcome to this Matlab tutorial. In this tutorial I am going to teach you how to design load flow analysis in Matlab Simulink software. I have taken an example from the book Power System Analysis by Hadi Sadat, Chapter 6, Example 6.7 as shown here. Consider the figure of the example, which consists of a generator at bus 1 and consists of 3 transmission lines with their impedances given in per unit. Among 3 buses, bus 1 is slack bus, whereas bus 2 and bus 3 are PQ buses consisting of loads. Using the Gauss Seidel method, determine the phasor values of the voltage at the load buses 2 and 3 accurate to 4 decimal places. And we have to find the slack bus real and reactive power. The mathematical solution of this example can be found in the Hadi Sadat book. For your convenience, I have uploaded the example solution in the form of PDF link in the description section. You can download it from there. Let's start. Just click on the Simulink icon to open it. Click on this icon to open a new model. First, we need to save it. You may save it with any name of your choice and in any folder. To design the load flow analysis, just look at the figure. We need voltage source, 3 buses, 3 transmission lines, 3 phase loads, and 3 phase measurement blocks. At first, we just bring all these components from the Simulink library. Then we will connect one another and put the values. Therefore, first we need a voltage source. To get this, go to Simulink library and go to SimEscape. Then click on Power System. Click on Specialized Technology. Now click on Fundamental Blocks. Click on Electrical Source. You can see here voltage source block is available. Take this block and bring it in the model. Now take the 3-phase series RLC branch from here to represent the transmission line and bring it in the model. Now take the 3-phase parallel RLC load from here to represent the loads and bring it in the model. Now take the 3-phase measurement block from here for voltage measurement and bring it in the model. Similarly, bring the load flow bus from here and put it in the model. Bring the RMS block from here and put it in the model. Bring the display block from here and put it in the model. Now we are going to put the values in these blocks according to the example data. Just double click on 3-phase voltage source. A window will open. It asks about the 3-phase voltage. As we know that bus 1 is slack bus, its base voltage is not given in the example. Therefore, keep the voltage as it is. Keep the frequency 60 Hz and angle 0. As we are not going to perform short circuit analysis, therefore uncheck this internal resistance icon. Click on the load flow and if it is showing then keep it same, otherwise change it to showing and click OK. Now connect this 3-phase source with 3-phase measurement block. Now connect this load flow bus here and double click on it. Keep the bus name as it is because this is bus number 1 and is working as slack bus. Base voltage by default is 25 kV. So keep as it is. Per unit voltage of slack bus as given in the example data is 1.05 and angle is 0 degree. Therefore change these values here and click OK. As slack bus voltage is 1.05 per unit, therefore for 3-phase voltage source we have to multiply it with 1.05. Otherwise the answer will be wrong. Now double click on 3-phase measurement block. A window will open. Change the voltage measurement to phase. It shows other options. Just click on voltage in per unit because we are measuring voltage in per unit. Click No for current measurement. To convert the voltage in per unit, it asks again the base voltage. Put here 25 kV as the base voltage and click OK. Connect the RMS block with the 3-phase measurement and connect the display with it. Double click on the RMS block and change the initial RMS value to 0 and press OK. Now connect the 3-phase measurement block with the 3-phase series RLC branch. Double click on it, a window will open. Change the branch type to RL. Just look at the figure. Transmission line from bus 1 to bus 2 has the resistance of 0.02 and reactance of 0.04 per unit. These values are given on a base of 100 MVA. Therefore, we have to calculate the actual impedance to put it in the model. We know that the actual impedance is given by Z actual is equal to Z per unit into Z base. To calculate the actual impedance, we need the base impedance. The base impedance is given by V square base upon S base. Here, base MVA is given as 100 MVA, but base kV is not given in the example. However, to put the value in the Matlab Simulink, we need the base kV. The default base kV in Matlab Simulink is 25 kV. Therefore, we assume base kV as 25 kV. However, you may choose any base kV value, it will have no effect in the Matlab Simulink results. Therefore, putting these values in the expression, we get base impedance equal to 6.25 as below. Now, actual resistance is given as below. Similarly, the Matlab Simulink asks the value of inductance in Henry instead of inductive reactance. And we know that inductive reactance is equal to 2 pi fL. And L will be equal to inductive reactance divided by 2 pi f. Therefore, actual inductance will become L is equal to inductive reactance multiplied with 6.25 divided by 2 pi f. Therefore, put these values of resistance and inductance in the model and click OK. Now copy the 3-phase measurement block and connect it here. Now connect the 3-phase parallel load block. Double click on the block, a window will open. Just look at the figure. The load connected on bus 2 is 256.6 MW and 110.2 MVAR. Now come to window again. Put here voltage 25 kV, frequency 60 Hz. Put here 256.6 MW and here 110.2 MVAR. Make capacitive load to 0. Go to load flow tab and change this load type to PQ because bus 2 is PQ bus and click OK. Now copy the load flow bus and connect here. Double click on it, a window will open. Change the bus name to bus 2 and per unit voltage to 1.0 and click OK. Just look at the figure again. Now we have to connect transmission line from bus 1 to bus 3 having resistance of 0.01 per unit and reactance of 0.03 per unit. To do this, copy the 3-phase series RLC branch and connect it in this way. Double click on it, a window will open. Just change 0.02 with 0.01 and 0.04 with 0.03 and click OK. Now copy the 3-phase measurement block and connect it here. Just look at the figure. The load connected on bus 3 is 138.6 megawatt and 45.2 MVAR. Now copy the 3-phase parallel RLC load block and connect it here. Double click on the block, a window will open. Put here voltage 25 kV, frequency 60 Hz. Put load 138.6 megawatt and 45.2 MVAR. Go to load flow tab and change this load type to PQ because bus 3 is also PQ bus and click OK. Now copy the load flow bus and connect here. Double click on it, a window will open. Change the bus name to bus 3 and per unit voltage to 1.0 and click OK. Just look at the figure again. Now we have to connect the transmission line from bus 2 to bus 3 having resistance of 0.0125 per unit and reactance of 0.025 per unit. To do this, copy the 3-phase series RLC branch and connect it in this way. Just double click on it, a window will open. We have to put the values. Just change 0.02 with 0.0125 and 0.04 with 0.025 and click OK. Now connect the RMS block and display block here for voltage measurement. Similarly, repeat the steps to connect the RMS block and display block at bus 3. Now you can run the simulation. Before running the simulation, we need power GUI block to run it, otherwise it will give error. To get this block, just write it in search term of Simulink library and enter. It will show the power GUI block. Copy this block and paste it in your model. Set the simulation time to 1 second. Now you can run the simulation. It can be noticed that voltage measurements are not correct. It is due to the reason that for load flow analysis we have to change the setting of power GUI block. Just double click on it. You can see it is fixed. To make it flexible so that we can change the settings, we have to change the solver. To do this, go to simulation and click on Model Configuration Parameters. A new window will open. At Solver tab, change the Auto Solver to ODE45 here and click OK. Now double click on Power GUI block. You can see now you can change the simulation type from continuous to phasor. Now go to Tools. Click on Load Flow Settings. It will show you the maximum iteration, frequency, base MVA, PQ tolerance, voltage units and power units. Keep as it is and press OK. One more thing we have to change. Just double click on 3-phase measurement block and change this complex into magnitude and press OK. Repeat the same procedure for other 2 3-phase measurement blocks. Now you can run the simulation. Compare the voltage magnitude with the magnitudes in the example solution. It can be noticed that both answers are correct. Now double click on the Power GUI block and go to Tools and click on Load Flow to perform the load flow analysis. Automatically a window will open. Just look at the window. It shows different bus types, bus names, their base voltages, given per unit voltages, angles, given loads connected at different buses. Other parts are empty. To get the results, click on Compute. You can see it shows all the values. It shows select bus real and reactive power. You can compare the answer with the answer obtained in the example. You can see both answers are correct. You can also see the voltage at bus 2 and bus 3 with their magnitude in per unit and angle in degrees. You can compare the answer with the answer obtained in the example. It can be noticed that all answers are correct. Friends, in this tutorial I have discussed how to design load flow analysis in Matlab Simulink software. I have discussed how to model slack bus, PQ bus and how to connect loads and transmission lines between the buses. By doing the same way, any power system can be designed in Matlab Simulink and its load flow analysis can be performed. I strongly recommend all of you to take IEEE 5-bus test system data and try it to build in Matlab Simulink software and perform its load flow analysis. Similarly, you can design IEEE 9-bus test system, IEEE 14-bus test system, IEEE 30-bus test system and so on. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.